Right, the agenda would be to see what it is and how to run it, where to run it, and probably you're also wondering how performant it is, because performance is the main selling point for it, from what I've heard at least. And there are many challenges while porting. It's not like you just take your C++ code and just port it and it works. Yes, you just put it in a bucket and mix it and it will just come out as a runnable code. It doesn't work that way. Right, so starting off the bat, what is it? It says on their website, it's a binary instruction format. Basically, it's a stream of instructions, which is easier to distribute than JavaScript. Those are instructions that get evaluated by a virtual machine inside the browser. And well, some go as far as calling it the Holy Grail of portability. Yes, if that sounds familiar to you, you're not alone. There were attempts, some of them failed, but this time around maybe we'll make it work. On Chromium, for example, we have tiered compilation, so that we can, just after downloading it or even streaming it, we can get executable native code, native instructions, and then we have TurboFun, which optimizes the entire flow, so that later on when we have it and we're already running this program, we're able to hot swap with better optimized code. So that's a nice thing to have. And a lot of languages are supported, but we're probably mostly interested in C++ as a C++ group. And it's pretty easily debuggable, so that's also our point of concern, probably. And as it says, its main goal is to enable performant applications on the web, but it's not limited to the web, which might be confusing. Also, it's not about only C++ or relatively low-level languages. It can be run on a web browser, which is the main execution environment these days, but also on Node.js, which I know some people use, and it's more performant there. And on WASM, which is still a bit experimental, but it tries to resolve some issues with modularity and with permissions on desktop and non-browser environments. Just this morning, around this very benchmark, and it says here that the FPS average is higher on this Toby Girl game, whatever it is. It's a WASM boy. It's an emulator of Game Boy made in WASM, not in C++, unfortunately, in assembly script, but still, yes, it does compile to WebAssembly. So it is WebAssembly, and here we see a TypeScript equivalent and a TypeScript with closure compiling, which is basically optimizing JS to JS. And various benchmarks exist, and they state that it's faster in some applications from 7 to 50%, so that's a substantial gain. So that probably could make it a target for you, make it work for you. VS Native, unfortunately, on web, it was tested initially on small, focused scientific kernels like dense matrix multiplications or numerical methods applications. So it was only 10% slower. Unfortunately, when there was another study later on, and there were larger, lifelike, let's say, applications, and they tended to be 52 to 150% slower. So that's a substantial. That's a bit of a degradation in performance. Right, and how do we use it? There is mostly, if you're targeting web, you probably should be looking at Emscripten, which is a complete toolchain. It uses LLVM, binary enclosure, and others to compile your C++ to work in WASM. Plus, it spews out some JS and other HTML that you need to run later on the browser, so it's also quite convenient. It does provide implementation of system APIs, which are notably missing, obviously, on the browser, like POSIX functions, TCP sockets, file access. This is all missing. WASM actually has to ship with it, and your actual module has to ship with it, because otherwise it won't work. So Emscripten is the hero who actually created this for you, and uses browser APIs to actually support all of this. As you can see here, they also allow you to call JS from your C++, which is a blasphemy or a blessing.
Or just necessary. Given that that's your operating
yes, it is necessary, as we will see later.
And suddenly you get no time zone data.
Yes. Yes, they skipped it, so it just shows how difficult it is. You can also transliterate from JS to C++, so you can do something like get me a document instance and get me something from it, like scroll. For you, it would be very useful. Scroll Y and set it to something, right? So we can do this from C++. You don't have to resort to any kind of JS madness. There is also a convenience code for other web APIs like WebGL. It translates OpenGL to WebGL, which is quite nice. And there is an interesting illustration from WASM, actually. This Emscripten would reside somewhere here, I guess, so that your WebAssembly module gets funneled into this pipe here and calls the browser, which goes its own mysterious ways to get to the kernel.
It's an excellent picture.
Yes, so it's
utter nonsense.
Yes, it is running in a sandbox, right? So we have to remember that the browser has the browser's render process is sandboxed for security purposes, so it has to do it this way. There's no way around it, unless you want to be attacked by hackers. So that's probably not what you would like. And the potential challenges which we have spotted while working on Qt. There were only 2 of them listed on Emscripten's site, so I wonder. Yes, but there are more, unfortunately, especially when you're writing library. Probably when you're writing an end application, that wouldn't be that many of them, but still, you could stumble upon some of them, so it's probably wise to know at least a couple things about those. So first off, the permissions. You normally don't have to worry about those, especially when you're Win32 programmer. You get access to everything. But not on the web, sorry.
You've got permission to do absolutely everything, and that's why the operating system
okay,
is
maybe you
secure.
can't operate in kernel as the kernel, but well, some of you might be also familiar with that when creating applications for macOS. So it's not entirely new, but the important bit here is that you have to request those permissions and you await a async callback. And the request has to be made during the so-called transient activation, which means that there is a certain delay after last user's action on the web page to prevent any kind of permission grabbing due to background script running. This is also for security purposes, obviously, because you wouldn't like that. And you have to remember that. And when you're when you're thinking about your program and how it behaves overall, what is the state machine, you have to think when to actually request those permissions, because otherwise you won't be able to use features. And asking for them in bulk is probably not the way to go, because who would like five pop-ups? You probably want to use files, right? Life would be very boring without files. And unfortunately, the file access is quite limited, because I wouldn't like any attacker or script on the web to pry on my personal files in my very personal file system on my computer. So the way Emscripten works, they have a couple of file systems that you can use. The default one is memfs, which is purely a memory and unfortunately volatile file system. So if you save anything to it, well, it's gone after reload and after crash, which happens sometimes.
Oh, there's some software involved.
Yes. Node.fs is something for Node, which you probably won't be running on the web, but still it's available if you want to. If you, well, let's not do it. But you might try. ID DBFS, right? So this one is actually the most sophisticated, and it gets access to. It gets access to a specific file that you can use, and but it has to be synchronized with memory fs by an async call. So when you're exiting or you can do it with a certain frequency, but when you're exiting the web page, you have to call some function to save your state. Well, that happens also in C++, right? You have to save it occasionally, so that's not a not a big problem, I suppose. And there is also another way but only on Chrome, obviously, because portability is. Yes, but if you happen to be on Chrome, or your client happens to be on Chrome, you can use show open save file picker, which allows you to access the actual file system. And you also have to have transient activation then, because of the aforementioned problems. And this was the main point for us in Qt. Async vs sync. This is a big problem because most APIs actually are sync when you think of it, like file access, file reading, writing, everything is sync. But on the web, conveniently, everything is async, or most of the things at least. And the way it works, it returns a promise which gets resolved after a certain time, because it has to actually call from the render process, it has to call the browser process, or maybe another utility process, as it sometimes happens. And it returns to you after this after this set of IPC calls. So yes, unfortunately it is async. But Emscripten is working this around by busy waiting sometimes, unfortunately, but yes, that's how it works. And a particular challenge for us was to start an event loop, which is important to mention is that you're running mostly on the main thread on a web page, which means that you have to return to the main thread so that the main thread has to do all the work that it usually does, like draw the web page or handle the events. Unfortunately, when you run a event loop, this all is gone. So you have to return to the event loop somehow. Emscripten allows for that, and also there's a possible solution for that. You can move the main thread to another worker, because I will talk about it a bit later, because there's threading slide also. And yes, there's this transliteration measure, which I mentioned, but unfortunately you cannot carry any state with it sometimes, especially in the case of promises. So we have we really had a conundrum here how to carry this state around, and we settled on some static pool of promises that you can call in the C++ code, of which there is only a limited number, and each of which has a state tied to them. And until they resolve, unfortunately, you cannot make any more promises. So that was also a huge challenge. About linking, you probably don't want to statically link. So yes, unfortunately, also on the web, because you do not have these system libraries, you have to carry them with one of the modules that you're going to link. This is called the main module, which weirdly enough doesn't have to specify a main function. But, Side module is something that only has user code. So the way it works is quite easy, at least from Emscripten creator's perspective. It just mixes all the modules together and searches for matches between defined and undefined symbols. Yes, and unfortunately this doesn't work with dynamically calling later when you were missing some system list, but I will show that later. And about load time of such things, if you happen to be using the site modules frequently in many end applications with these main modules, that's okay, you don't have to be main. You can replace probably that one, which would contain main. Anyhow, the load time might be amortized by browser cache. So this is probably something useful, at least. And a symbol removal tends to be very aggressive in Emscripten to conserve memory and to make the binder small because we want to save bandwidth. This problem doesn't probably concern classic traditional applications not taken off the web because well, they get loaded from the disk, right? Right, so it tends to be very aggressive, and the problem is that sometimes you have this system lib in a module, and you need a certain function to call after you have linked, but unfortunately this is missing. So you have to set such a function for inclusion during the linker stage. So possibly you need to access file system from the outside when you have compiled the module. Well, you cannot do this just like that if you're not actually referencing the file system, whatever function from your code. Right. How to execute your app for outputs. It's sometimes you want to make your app a stage in a longer chain of calls. Right, so making this work usually goes through Emrun, which is a program that does some fairly complicated stuff to just output the program's STDIO to the screen. It sets up, for one, it sets up a local server which is listening for post requests from the program. So that's probably not ideal, but sadly this is the only way to do it unless you want to regex on browser's output, which I would recommend. Right. And the other ways are just simply launching the generated file, which probably won't give you any output, and writing the running code yourself. Right, we skip that one. And there's interestingly there is threading, which is also implemented via web workers. Unfortunately, they need shared array buffer to work because you need to exchange memory and synchronize between them. But this is the easy part because you just have to specify certain headers that the server returns. There is also an extra worker file generated that you have to host on your server, so that's also a bit of a problem, but not a big one. But there are quirks, and those are really interesting sometimes because you don't get them on not on the web. Like some calls from child threads, which are workers actually. Workers cannot do certain operations like access the DOM, document object model, so they get implicitly proxied to the main thread. Unfortunately, when the main thread is doing something like waiting for the aforementioned child thread, it will just deadlock between these two threads. So that's a bit of a problem then. And yes, proxying is implicit, so you have to be very wary of what you're doing. Right, and there is also to work around that. T-thread create also needs to return to the main event loop, like I mentioned before, to actually create a worker, but if you happen to be running only a couple of those, then there is this pool of threads which get created at the beginning of execution of the program. Right, and you can also proxy to the threads, the main thread. Right, and there are also memory areas which, yes, you have to interchange memory between, like the JS memory and Emscripten heap, and sometimes the copying operations tend to get costly, but you can work around that by creating a memory view. But yeah, it sometimes doesn't work, so we have to also be mindful about not copying too much between memory areas and thinking about that, because it will deteriorate your experience. Right, so all in all, yes, if you're into portability, then probably this is the thing for you. And I think that's the major selling point here, and it might work as the holy grail. As the holy grail of, I mean, it does work, but as the holy grail, I wouldn't call it so until we see proof for that. Yes, thank you. And it doesn't end. By default, the runtime does not exit because you might have some async stuff going on, so it doesn't really flash STDO streams, doesn't destroy code global destructors, and not exit. So you have to use this if you want that, but I didn't use that.